graphing inverse variation. So we're going to continue to work with our inverse variations here. We're going to graph each variation if y varies inversely as x. So let's take our y equals 9 when k equals -3. So let's figure out what the constant of variation is here. So I'm going to take my x, y equals k. I'm going to plug in my x and my y, and I find that the constant of variation equals -27. So this equation looks like x times y equals -27. So what I'm going to do is I'm going to make a table here. This isn't slope-intercept form. This isn't linear. This is kind of an equation that we haven't really seen before as far as graphing it. So let's see what it looks like as a table. Remember, if you need to make a graph of some equation and you have no idea what to do, table is always the way to go. So let's start with the table. Now I picked some numbers for x that I knew would be friendly. I decided not to just do, let's just do 1, 2, and 3. I decided to work with numbers that weren't going to give me disgusting numbers as my output. So I grabbed -27 for my x, which means y is going to be 1. Grab -9. So -9 times 3 is -27. -3, so I'm just doing factors of 27 here. -3 times 9 is -27. -1 times 27 is 27. Now notice what happens here in the middle. I get to 0. I can't use 0 as x or y, because if I multiply by 0, I can't get a product of -27. So x can't be 0 and y can't be 0. So I kind of have this blank space in the middle of my table here, which is going to look weird when we get there, but I can't use 0 in there. So then I skipped to some positive values of x, kind of mirroring what I had less than x, less than 0. 1 equals -27, 1 -27, 3 -9, 9 -3, 27 -1. So this is what I ended up with this table. So now I'm going to graph it. So notice what this looks like when I graph it. I have -27, 1, -9, 3, -3, 9, and then -1, 27. So I end up with this. We've kind of seen this before when we're working with exponential functions. This is kind of that, it looks like a water slide there. We end up with this looking graph here. It gets really close to the x-axis, but again, remember, it can't get actually to the x-axis because we can never have x actually be 0, because if x is 0, then the whole equation kind of goes funky. So this is going to get really, really close to 0, but it's never actually going to touch 0. Same thing going this way. This part of the equation is going to get really close to y, but since I can't have y actually be 0, it can't actually end up on the y-axis. So there's no x-intercept here, and there's no y-intercept. It never actually touches either of those axes. Now the other side kind of looks the same, only kind of a mirror image of it. So I come down here to 1 -27, 3 -9, 9 -3, and 27 -1. So I end up with that same shape, just kind of upside down and reversed, mirror image of it. And again, we end up with that same thing where it can't touch the y-axis, it can't touch the x-axis, because that would mean that number is 0, and then I'd be saying that 0 times something is equal to a non-zero number, which we know can't actually work. So we end up with these two shapes. So this is called the hyperbola. We're going to get to that. We're going to keep working with these as we go along, but we end up with this kind of water slide shape there. It never actually touches the bottom there. All right, so that's what our graph looks like. Let's take another instance where we're going to see the same type of graph here. Suppose you drive 200 miles without stopping. The time it takes to travel a distance varies inversely as the rate at which you travel, which makes sense. Faster you go, less time it takes. Let x equals the speed in miles per hour, and y equals the time in hours, and we're going to graph this variation. So I grab my distance equals rate times time formula. I plugged in 200, so I have x times y equals 200. So again, I'm going to make a table, and I picked some values that were friendly to work with. I'm only picking positive values because we're not going to have a negative number for our rate, for our speed, or for our time. So I grabbed 1 as my smallest. Again, I can't use 0 here as my rate, because if I don't travel any miles per hour, I'm not going to ever get to that 200-mile distance that I want to go. So I can't use 0. So 1, 200, 2, 100, 4, 50, and I went all the way through up till a nice integer that worked there, 200. So now when I graph these, I end up with 1 200s off my graph, 2 100s off my graph, but 40, 50 I can put on there. 450, so here's 450, and then 540, and then what do we have? 10, 20, and then 20, 10, and then I went to 45, and then I went to 54, and then they were too big to fit on there. But again, you'll notice I have that same hyperbola shape there, that water slide roller coaster shape. Again, I can't ever touch the y-axis because I can't have a 0 in here for my time. If I don't travel any time, I'm not getting 200 miles. And same thing for my x. I'm not actually going to touch that x-axis. So this is what we look like when we're graphing an inverse function.